Hello, welcome to CWI Part B Practical Book of Specification Lecture. This is lecture 18. Today I'm gonna give a lecture about chapter 5 and tension test criteria. Let's go to page 23. And we start from this 5.4.3 tension test criteria. I'm gonna read out the specification and give you the explanation and show you the pictures of the test. The procedures and method for tension test shall conform to AWS-B 4.0 standard method for mechanical testing of welds. Note, B 4.0 is referenced but not needed when taking this examination. So this AWS-B 4.0 is not required for the CWI Part B examination. Each tensile test specimen should have tensile strengths not less than the following. So the tensile test acceptance criteria is from 5.4.3.1 to 3. For four items and give you the explanation. For 5.4.3.1, the minimum tensile strength of the base metal as specified in Annex 3B or of the weaker of two base metals if metals of different minimum tensile strengths are used, or the minimum tensile strengths. You can find the minimum tensile strengths in Annex 3B, which is here. This is Annex 3B, this page is 37 in Part B, Book of Specification, M number listing of base metals, ferrous alloys. So here you can see material number and group number. Material number is M number. This M, material M stands for M. So material group number 1, material number, and group number standard, which is like A36, ASTM A36, A106, 106, grade C, grade B, and UNS number, Unified Numbering System, is K03006, and thickness limitation, non-NA, and minimum tensile yield strength here. This is important. Minimum tensile strength in MPa, Pascal. So minimum tensile, the prior one for ASTM A106 grade B, minimum tensile strength is 5. Why am I read this 4 continuously 5? I don't know, I'm sorry. This 415 MPa is the minimum tensile strength, and yield strength is 240. 240 is the yield strength, minimum yield strength, and product form is seamless pipe, and nominal composition, the chemical composition is carbon, manganese, and silicon. This is Annex 3B, and if you weld two different metals like ASTM A106 grade B and ASTM A106 grade C, then it says weaker of two base metals if metals different minimum tensile strengths are used. The criteria for the tensile strengths, minimum tensile strength, is the weaker of two metals. So if I weld two metals, two pipes like ASTM A106 grade B and ASTM A106 grade C, the minimum tensile strength is for A106 grade B is 415 MPa and minimum tensile strength for A106 grade C is 485. So weaker of these two meters is this 415 MPa. So you select this one as acceptance criteria. This was 5.4.3.1. Next is 5.4.3.2. Specified minimum tensile strength of the electrode or philometer classification when undermatching philometer is used, or so the specified minimum tensile strength of the electrode or philometer, so the consumable classification when undermatching philometer is used, or so what it means is here I am welding this ASTM A106 grade B. So tensile strength, minimum tensile strength of the ASTM A106 grade B is 415. However, I am using the undermatching philometer, which means, let's say I am using SMAW process, shielded metal arc welding, and E70, not 70, 60, 11. Then the tensile strength of the 6011 is I guess slightly less than this 415. Not sure how much. Let's calculate KSI to MPa. Calculation. Oh, 1 KSI is 0.703. So this 60 is KSI. 60 PSI or 60 KSI is the philometer. The MPa, the tensile strength. Then convert this one to MPa is 60 KSI times 0.7 something 0.70306 0.70306. Then calculate this one. 60 times 0.70306. This is 42. Bigger than this one. 420. This is not a good example. I'm sorry. Let's say not this ASTM grade B. Just select ASTM grade C. Then the minimum tensile strength of the ASTM A106 grade C is 485. Then definitely this minimum tensile strength is greater than this electrode tensile strength, 60 KSI. This KSI is smaller than this 485 MPa. So this is undermatching. Then you or me you select this tensile strength of this electrode, not the base metal. Tensile strength acceptance criteria of the minimum tensile strength is electrodes. This is 5.4.3.2. I have a problem reading 5 as 4. 5.4.3.3. If the specimen breaks in the base matter outside of the word or word interface, the test should be accepted provided the strength is not more than 5% below the specified minimum tensile strength of the base matter, or something something something. So 5.4.3.3 is specimen breaks. So I'm going to show you the picture. This is bend test specimen. This is tensile test apparatus equipment, and this is reduced section tensile test specimen. So this one here, you apply tensile load upward and downward, and this part becomes thinner and thinner, and eventually fracture occurs, something like that here. So tensile test specimen, reduce the section and apply tensile load upward and downward, then tensile specimen becomes like here, 1, 2, 3, becomes thinner and thinner and thinner, and finally necking and fracture. But what it says is the specimen breaks in the base matter outside of the word or word interface. So the specimen breaks outside of the word, which means this is the center is word and word interface, but breaks occurs here, something here, not here, not here, but here in the base matter. Then the test should be accepted. The tensile strength, tensile test acceptance criteria becomes like this: strength not more than 5% below the specified minimum tensile strength. 5% below the specified minimum tensile strength, which means here, erase everything, and we worded ASTM A106 grade C. So tensile, minimum tensile strength of the ASTM A106 grade C is 485 MPa. So 485 MPa. I'm gonna write down equation first. 485 MPa times 5%, which is 485 times 0.05 is, then I use the calculator, 485 times 0.05, which is 24.25. 24.25. Then what it means here, 5.4.3.3, provided the strength is not more than 5% below the specified minimum tensile strength of the base matter. So the tensile test, if the tensile test specimen breaks in base matter outside of the word or word interface, the tensile strength tensile strength test, the acceptance criteria becomes not this 485, but becomes 485 minus 24.25, which is not more than 5% below, which is 485 minus 24.25 is 460.25. 460.75. When the tensile test specimen breaks in the base matter, this is the new tensile test acceptance criteria. Not this 485, but it becomes 460.75. Why? Not more than 5% below. Tensile specified minimum tensile strength of the base matter. So this 5.4.3.3, I have the sample question, something like this. Table 1, this is table 1, tensile test result. Width and thickness, width times thickness is area. Base matter is ASTM A106 grade C. Tensile strength minimum value is 485 MPa. It assumes width and length area loaded are correct. This condition, let's forget about this condition. Is it acceptable? So I'm gonna show you how you read this table specimen number 1 and 2 width. This is width, and this is thickness. So 18.8 times 12.9. This is 18.8 times 12.9 is, this is millimeter, and this is millimeter, and the area is 242.52 millimeter square millimeter. This is the area. This is square meter. If you convert this one to square meter, right here, square meter, then times divided by million, 1 million, then 0.000024252, which is same number as here. But forget about this square meter. This is area. Holy, I'm losing this one. Change the color to red. And this area, and we have ultimate total load, Newton, and ultimate unit strength, unit stress, MPa in MPa 486. So 486 MPa divided by this 242.52 millimeter square millimeter. Then this is 486 divided by 242.52 is a weird number came out. Oh, I'm sorry. I made a mistake. Not the MPa. This load 865. I'm sorry. I'm gonna do the calculation again. 117,865 divided by 242.52 is 486. So this is 486 MPa. So tensile strength unit stress is 486, and the type of failure at the location is base metal. What it means is we apply the tensile strength test for the reduced section specimen, and the fracture point is here, base metal. And the minimum tensile strength specified is for ASTM A106 grade C is 485 MPa. And I can find this value here in Annex 3B. Annex 3B here. And ASTM A106 grade C, the minimum tensile strength is 485. So this specimen number 1 is acceptable because the minimum tensile strength value is 486, but the acceptance criteria for ASTM A106 grade C is 485 MPa. So the tensile test value is greater than this minimum tensile strength value for ASTM A106 grade C. So specimen number 1 is acceptable. Let's do specimen number 2. Erase this. We're calculating specimen number 2. I write down equation 18.7 times 12.7. Then 18.7 times 12.7, which is 237.49. 237.49. This is again square millimeter, and here ultimate total load 112,095, and divide by this area 237.49, which is 112,095 divided by 237.49 is here 471.99. So round it 472, and the fracture location, failure location is base metal. Then we need to think about acceptance criteria for the tensile strength of the ASTM A106 grade C in 5.4.3.3, because the fracture location is base matter, not the fracture. The fail location is base matter, so we apply this strength is not more than 5% below the specified minimum tensile strength. So calculate this 5% of 485. 485 times 0.05, which is 24.25. So 485 minus 24.25 is 460.75. 460.75 is the new acceptance criteria for the ASTM A106 grade C when the test specimen breaks in the base matter. But the tensile test value is here 472, which is bigger than 460.75. So this test number 2, specimen number 2 is also acceptable. This is how you calculate the tensile strength load and tensile strength acceptance criteria. Little bit complicated, but if you practice it continuously again and again, and not that difficult. Let's go to 5.4.3.4. If the base matter has no specified minimum tensile strength, then failure in the base matter shall be acceptable. Let's say base matter is not listed in the Annex 3B or unlisted material, so we don't know the minimum tensile strength of the base matter. Then the tensile test, if the tensile test is applied to the unknown base matter, then if the fail occurs in the base matter, then that test is acceptable. Wow, I have a problem reading this 5 to 4. I'm really sorry. 5.4.4 CVN fracture toughness criteria. For fracture toughness testing, the type of test, number of specimens, and acceptance criteria shall be as specified. So in the WPS and PQR, the CVN Charpy V-Nachi fracture toughness criteria, the toughness testing type and number of specimen shall be specified in the PQR. Again, the similar thing as tensile strength, the procedure and apparatus shall conform to the requirements of AWS B 4.0 standard method for mechanical testing of weld. Note, B 4.0 is referenced but not needed when taking this examination. So for CWI Part B examination, this AWS B 4.0 is not a requirement. Procedure qualification documentation. Welding variables used to produce an acceptable test weldment and the result of test conducted under weldmeter weldment to qualify WPS should be recorded on a welding procedure qualification, which means PQR, record PQR. The PQR may be presented in any format within or written or tabular. The suggested format for the PQR is included in Annex 7. The WPS shall reference all PQRs which support the qualification of the WPS. So, this PQR format is listed shown in Annex 8. Let's go to Annex 8. This is next 8 procedure qualification record, and we have a tabular format and very common this PQR format. And here in the test section, visual recognition and tensile test, which is table like we just saw in here. And next is guided bend test, and when required, CVN Sharpie V-notch test is specified here, and type and number of tests shall be specified in the PQR. Okay, this is chapter 5, and I explained everything about chapter 5, so I'm gonna stop here today, and next lecture I will explain chapter 6, Clause 6 here, and this is the last chapter in this CWI Part B Book of Specification. So thank you for listening my lecture, and I will see you next time.